Tutorial I'm going to go over A91, and that is in the standing waves. So we're going to start our conversation with something we already talked about, and that is the periodic wave. Oh, by the way, you're going to be able to discover three things from this tutorial. Number one, you're going to be able to discover the conceptual understanding of a standing wave, then mathematical understanding of this standing wave, and then finally the wave equations, right? Good. Number one, what is periodic wave? So periodic wave is the wave is just a periodic disturbance without any endpoint, right? And how can you draw this? Imagine a rope, and you move it up and down, and you create a wave. And this wave has no endpoint. How the endpoint would look like? This is the endpoint. So there is no endpoint. So this wave move continuously forward, right? Okay. So we can define the wave. Wave is a disturbance, a periodic disturbance, right? Without endpoint, right? So we should be able to write the equation for the wave. So equation for the wave is y x comma t is equal to amplitude sine kx minus omega t. K is 2 pi over lambda, and omega is 2 pi over period, right? The kx tells us that this wave is a function of position, right? It is moving to the right. And the omega also tells us that these waves, as the time passes, like if elapsed time increases, then it will create more cycle, right? Okay, so this one talks about the cycle with respect to the time, and this one talks about the position at the x direction with respect of time. Okay, now let's use this understanding to define this standing wave. So standing waves, the same definition. Disturbance, right? A periodic disturbance with two endpoints. Okay, let's consider guitar as an example. Let's construct the guitar, right? Guitar is a good example of standing wave. So guitar has a two endpoint, right? And a rope in the middle. Okay, that's the guitar. What can you do? You can create a wave now. If you do create a wave, right? What happened? As soon as the wave go to the end point, it bounce back, right? Okay. So this one you call it. The incident ray, and this one you call it reflected ray, right? And how do you create that? Consider a rope again, right? A rope. So if you move up and down just once, it creates a pulse, right? If there is no endpoint, this pulse will move forward. But if there is an endpoint, since it is a guitar, it's going to move over there, right? It's going to move over there, and it's going to bounce back with same magnitude but opposite direction. Maybe this is not same magnitude. To accomplish same magnitude, I have to use this one. Okay. Oh, sorry. Let's do it again. I'm going to use this one. It makes 180 degree shift, 180 degree phase shift. Okay. So this one is moves this direction, and this one is moving this direction. Okay. This one is moving this direction. Okay. Now I want you to write the equation for this one and equation for this one, right? So equation for this one would be y is equal to y1, let's say y1 is equal to amplitude sine kx minus omega t. Minus means it's moving to the right. And now let's write this one, y2 is equal to a sine kx plus omega t. Omega t meaning that is moved to the, of course, left. For example, if I draw this one, draw x, draw this and this, right? Draw this one over here and this one over here. How can I write the equation for this one? Equation for this one gonna be similar to this. Y is equal to x minus 1 squared. This is 1. Y is equal to x plus 1 squared, meaning this is 1. Okay, so this works just like algebra. Good. Now, if this wave come over here, then what happens? Okay, or if it waves come over here and bounce back, right? Bounce back. It comes over here and it will bounce back, right? It will bounce back again 190 degree, 180 degree. Then what happened over here? Over here there will be a wave. The black one plus red one, there will be like that, right? Okay, and what would be the equation for that one? The blue one. So equation for the blue one would be the black one plus the red one. So you have y1 plus y2, y1 plus y2 is equal to, you're going to say big Y, which is x comma t. You want to write a plus a is of course 2a. And this, unlike two things you should discover, two things. Discovery. Similarity and difference. The difference would be, unlike the periodic wave, this wave cannot move forward at the x direction because it's confined by two barriers, right? So this is the difference between the periodic wave and the standing wave. What is the similarity? This is the similarity. Just like the periodic wave, the standing wave cycle. You can make more cycle if you spend more time. Time increases, cycle increases, just like the periodic. Okay, so that are the similarity and differences. Okay, good. So A to A, that sine, right, you're gonna get exactly same thing. Cosine, you have omega t. Okay, I'm gonna derive this equation in a different tutorial because this tutorial is gonna be half an hour long anyway, so I don't wanna make 3 hour long tutorial. Okay, so now the next thing I want to talk about is harmonics. So what is harmonics? Harmonics is a type of waves, right? Is a type of waves that satisfy the multiple integer of the frequency from the first harmonic. What am I talking about? Multiple integers. So this is an integer. What is integer? This is an integer, positive integer. So this means n means positive integer. What is positive integer? 1, 2, 3, 4. So it allows only whole number, positive whole number. Oh, whole number is just from 1. Okay. So what is harmonics? Harmonics is n multiple of frequency coming from only fast harmonics. Okay, so that's what it is. So we're gonna prove that. We're gonna prove what does that mean. Okay, so let's consider fast harmonic, because speaking of fast harmonic, we're gonna have to draw a guitar. And let's draw a guitar string, right? Let's start our conversation with a guitar string. It's the same guitar, so it's gonna be same length. So you're gonna have the same length, or same guitar. So you're gonna call length L, length L, length L. What can we do with this guitar? Remember, you cannot have guitar without the end point. So let's make really guitar, 2 end point, right? 2 end point make a guitar. 2 end point make a guitar, right? Okay, good. What you can do, you can plunk it. You can move it up and down. If you do that, then it can create fast harmonic. Fast harmonic, by definition, is how many lambda here? Half lambda. So half lambda. So L L is equal to half lambda. By the way, as soon as the wave realizes that there is a barrier on the side, it's going to bounce back with equal magnitude and opposite direction, right? Okay. Here, the string doesn't move. And we can write the string doesn't move, but we should write note because that's what they call it. So, here, how many nodes? You have 2 nodes, right? And at some point, maybe here, at some point, there is a point, just one point, where there is a maximum displacement, right? We call it anti-node. So how many nodes? 2 nodes, and how many anti-node? Just 1. 2 node, 1 anti-node. Only 1 loop. Okay. We want to draw, this is first harmonic. If you have 2 wavelength, then you call it second harmonic. Is this a second harmonic? No, this is not a second harmonic because this is just 1 wavelength. Is this a second harmonic? No, this is bigger, but it's still 1 wavelength. This is the second harmonic because this is 2 wavelength, right? It's bounced back with equal magnitude and opposite direction, right? This is 1 cycle. By definition, this is 1 cycle if I do it 1. If I do it twice, then it's 2 cycle. If I do it 3 times, then it's 3 cycle. 1 cycle took me probably 10 seconds. Second cycle took me again 10 seconds. Because I'm human, I didn't probably take the same amount of time to draw the second cycle. Third second probably take 2 seconds, maybe 3 seconds. Okay. 4th cycle, if I do it like this, draw it like this, it takes longer than 10 seconds. You get it. So now how many cycle here? 1 cycle, 2 cycle, 3 cycle, 4 cycle, and so on. So you can have as many cycle as you want, but if cycle increases, time increases, cycle increases. Okay, good. Now here, this is second harmonic. What makes the second harmonic? 2 loop. Good. Lambda. Why lambda? Because it's just 1 wavelength. Half, 1 wavelength. So L is equal to, what are you going to say? Lambda. Good. Now, is this third harmonic? No. This is still first harmonic. Is this third harmonic? No. This is second harmonic. Is this third harmonic? Yeah, this is third harmonic because this is how many wavelength? 3 times 1.5 wavelength. Good. So now it bounces back with same magnitude and opposite in direction. Okay, as you see, this is more than 1 cycle, 1.5 cycle, if you do it once. Okay, good. Now, what can you do? How many nodes? There are 1, 2, 3 nodes. 3 nodes. Antinode, 1, 2. Antinode, 2 antinode. Okay, here 1, 2, 3, 4 node. Node 4. Antinode 1, 2, 3 at the maximum displacement. Okay, so what? How many wave length over here? So you have 3/2 lambda. Okay, so 3/2 lambda. L is equal to 3/2 lambda. Okay, so let's see. We want to define them in terms of lambda, not in terms of L. By the way, L is the string size. The string size, can the string be 10 meter? No, I never seen a guitar with 10 meter string. I seen this. I seen guitar with like 0.6 meter long string. So yeah, it's always reasonable. Okay, good. So now lambda is, as you see, 2L. Lambda is L. Lambda is 2L/3, right? Lambda is 2L/3. Now, watch what I do. I'm going to divide by 1, I'm going to divide by 2, I'm going to divide by nothing. Which one is correct? This one is correct, but this one is wrong. So if I have to divide that by 2, I have to multiply by top by 2. So why did I do that? I did that so I see the pattern, so that I can write nth harmonic, right? nth harmonic would be if the first harmonic is 2L over 1, second harmonic 2L over 2, third harmonic 2L over 3, n harmonic would be 2L over n, and n is the antinode, or n is the loop, whatever is easier for you to remember. Okay, good. Now, this next thing we're gonna do, we're gonna try to find, so I told you the harmonics. So harmonics is, what is harmonics? Harmonics is NF1, and we are heading that direction. We're gonna prove why the harmonics is NF1. All right, N is the integer, positive integer, and F1 is the frequency of the first harmonic. All right, so you're gonna only keep the first one, and we're gonna erase everything else, and we're gonna just write lambda n is equal to 2L over n. That's the progress we made, so we're gonna report our progress. Oh, I still have this one over here, so I didn't have to write it over there, but okay. Velocity is lambda times frequency. Frequency of who? Frequency of nth. If I have to use the frequency of nth, I have to use the frequency, the lambda of nth. So lambda of nth is equal to velocity over nth frequency, right? Okay, so far so good? Good. So what is lambda n? Lambda n we discovered 2L over n is equal to V over Fn, right? Okay, so we are making slow progress. Come over here. You have to, before you go there, you write 2L, Fn is equal to Nv. So Fn is equal to Nv over 2L. Now V over 2L must be this one. How is that? Would you be able to pause the video and discover it for yourself? Okay, come over here. We're going to discover it together. So velocity is lambda of frequency. Frequency of who? 1. The lambda of who? 1. So then frequency 1 is velocity over lambda 1. Frequency 1, what is lambda 1? Okay, so L is 1 over 2 lambda. So lambda is 2L, right? We discovered it before. So velocity is lambda 1 is just 2L. So frequency 1 is velocity over 2L. So frequency n is n1. So we proved that. 2, 3, and 4, right? Let's do it for this, for harmonics. Okay. So the first one, how the first one would look like? Let's use the different color. Let's use the let's draw it first. Let's draw the guitar first, right? Okay, now let's draw the first harmonics, right? First harmonic is half wavelength, right? Okay, so I'm gonna just write L is what is L? L is half wavelength, right? Okay, the second harmonic is all right, just wavelength. L is wavelength. It's bounce back, don't forget that. This is, well, 3 over 2 wavelength. 3 over 2 wavelength, right? Okay, don't forget that this is bounce back. 2 wavelength. Okay, good. Don't forget this bounce back. Okay, good. Loop, 1 loop, 2 loop, 3 loop, 4 loop. Note, 1, 2 note. 1, 2, 3 note. 1, 2, 3, 4 note. 1, 2, 3, 4, 5 note. Antinode. Antinode and loop are the same thing. Lambda. Lambda is 2L. It comes from here. Lambda is L. Lambda is 2L over 3. N V over 2L. N would be 1. Frequency is N V over 2L. N would be 2. Frequency is N for second third harmonic. N V over 2L. N would be 3. Fourth harmonic. N V over 2L. N would be 4. Velocity is frequency times lambda. Frequency times lambda. Frequency times lambda. Frequency times lambda. All right. Velocity is distance over time. Or velocity is lambda frequency, and they are the same thing, right? And also we're going to discover that velocity is lambda frequency, which is as same as the small frequency big lambda. Okay, if lambda go big, frequency go small. If frequency go big, lambda go small. That's what it means. Okay, so a few things you're going to discover. First, discover that this one. Okay, let's discover this one. Velocity is distance over time. Is that true? Okay. Well, if we write velocity is distance is how much? What is this string? What is the rope? Guitar string 0.865 divided by 0.068. That would be wrong. Why? Because we first have to construct the wave, right? Okay, let's see. Construct it. Okay, all right. And that's not it, right? That's not it. So it has to come back over here, and now you can use that information, right? So you have to, velocity is 2d over t. So velocity is 25.44 meter per second. Let's say this one also gives us 25.4 meter per second. First harmonic is, let's draw all the harmonics. Let's draw the guitar first. So this is the guitar. So first harmonics, second harmonics, third harmonics. All right. Okay, lambda, where is the lambda? Lambda is for first harmonic, lambda is 2L over N. So 2, L is how much? 0.865. 865. See, I'm multiplying by 2. N is in the anti-node or loop, one loop. So, okay, and that is how much? Let's see. 2 times 0.865, and that is 1.73. 1.73. So the velocity is 15 times 1.73 times 15, and that would be 25.95. 25.95. Okay, now let's do this one. Lambda 2 is equal to 2L over N. So that would be 2 times 0.865 divided by 2, because one loop, two loop. So 2 to cancel, so 0.865, that's it. So now I have a bigger frequency, smaller lambda, 0.865. So I have 0.865 times 30, and that is 25.95. 25.95. Wow, that's awesome. Let's find this one. Lambda 3 is equal to 2L over 3, because 1, 2, 3 loop, which is 2 times 0.865 divided by 3. 2 times 0.865 divided by 3, and that is 0.58. 0.58, which is a small wavelength, but peak frequency will compensate and give us to 25.95. So 0.58 times 48 give us 27.84. 27.84. So let's take the average. 25.95, 25.95, 27. So let's say average is about 26. You're going to draw the Pearson error. The Pearson error is 26 minus 25.44, like this one right here, divided by 26 times 100%, and that will give us about 2% human error. Okay, so we can accept that. We can say that this formula is equal to lambda times frequency. Okay, why this 2% error? It's just a calculation error. All right, guitar string is 1.2 meter long, right? I want you to find the first harmonic, wavelength for second harmonic, wavelength for third harmonic. So wavelength, so this is 2L over N, this is 2L over N, this is 2L over N. This is N is 1, this is N is 2, because 2 loop, and this is N is 3, because 3 loop, right? 2 to cancel, right? 2 times 1.2, that is 2.4, this is just 1.2, right? Because L. and this is 2 times 1.2 divided by 3, and that's it. Now we're going to do the last one. I have a string size, I don't know, length is 6 meters. Okay, so I'm going to do second harmonic, right? I'm going to create 2 loop. 2 loop, okay? 2 loop means 1 cycle, right? So count the second, 1 cycle, 2 cycle, 1 cycle I took like 2 seconds, 2 cycle I took 4 seconds, 3 cycle. How many cycle did I draw? I don't remember. Let's see how many cycle I did. 1 cycle, 2 cycle. Okay, let's say I did 3 cycle. 1 cycle, 2 cycle, 3 cycle. 3 cycle I did with the 2 loop. 3 cycle, 3 loop, 2 loop, and it took a long time. I don't remember. Let's make it up. It takes to do 3 cycle. I don't know. It takes 4 seconds. Okay, good. I want you to find the frequency. All right. So frequency is cycle over time. Cycle is 3 cycle. The time is less than 10 seconds. It's easy. 10 seconds. 10 seconds. So frequency is 0.3 hertz. All right. So now we're gonna find the period. Period is 1 over 0.3. So 1 divided by 0.3, and that is 3.3 second. Now let's find lambda. Lambda is 2L over n time is what harmonic is this? Second harmonic. So 2, and then is 6, right? So 2 to cancel, lambda is 6. So now velocity is lambda times frequency. Lambda is 6. Tired. The last time I ate like in the morning. Understand this problem, then even if you pursue a PhD in physics, you would still be able to use this understanding. Okay, all right, so let's go over this. Node, 7 nodes. So I'm gonna have to know what harmonic it is. 7 node means 7 minus 1, 6 harmonics. So let's draw the 6 harmonics. What harmonic is this one? First harmonic, second harmonic, third harmonic, fourth harmonic, fifth harmonic, sixth harmonic. I stop because there is a bad bounce back with equal in magnitude but opposite direction. Okay, good. So how many nodes? 7 nodes. How many anti-node? 6. How many loop? 6. Okay. All right. Fast thing fast. I want to find the velocity. Velocity is next time I'm gonna prove this equation. I'm so tired now. Mu is, we're gonna find mu is mass over length. Mass is 0.137 kilogram. Length is 4.35 meters. Okay. Mu is density by the way. You can use density. 0.137 divided by 4.35, and that is density is 0.315. Okay, kilogram over meter. This is mu actually. Let's call it mu. Let's use the convention. Okay, so F is 125 divided by 0.315 square root. So square root 125 divided by 0.315, and that would be 19.9. Is that right? Velocity is, let me check, double check. 0.315. Okay, so square root 125 divided by, let's see, 125 divided by, let me double check this one. 0.137 divided by 4.35. Oh, that was wrong. So mu is 0.0315. Okay, so that's why I'm getting the wrong answer. When answer doesn't make sense, you stop and double check. So 125 divided by 0.0315, take the square root, and you get 63. So 63 meter per second. All right, good. So now the first thing you're gonna do is, let's do everything over here as much as you can. Let's write on the velocity. Velocity is, we found the velocity. Velocity is 63 meter per second. So we're gonna write it, velocity is 63 meter per second. Now let's say we're gonna find the frequency of first harmonic or sixth harmonic, because this is sixth harmonic. Frequency of first harmonic is n 2l over velocity over 2l. Okay, so this is 6 because it's sixth harmonic. Can you have 5.1 harmonic? No. Velocity is 63. 2 times l is 4.35. Okay, so 63 divided by 2 times 4.35 times 6. So frequency is 43.44. So frequency of sixth harmonic is 43.44. Frequency of first harmonic is just divided by 6, and you want to get 7.24 hertz. That's frequency of first harmonic. We're gonna find the period. Period is 1 over 43.44. 1 divided by 43.44, and that will be 0.09 second. Okay, so few information. We have period, we have frequency, we have everything. Now let's go write it. Y of t is equal to amplitude. I also gave you the amplitude. Amplitude is 0.007. So amplitude sine kx cosine omega t, right? All right, so let's write a yt is a 0.007 sine. Let's find k. K is 2 pi over lambda. Lambda is, what is lambda? We found the lambda. Lambda is, oh, we didn't find the lambda. Let's find the lambda. Lambda is velocity. Lambda is, what is the lambda equation? Lambda equation is 2l over n. 2l over n. So lambda is 2 times l is 4.35 and n is 6 because it's just 6 harmonic. So 2 times 4.35 divided by 6, and that is 1.45. So lambda is 1.45, and this is 6.28. So 6.28 divided by 6.28 divided by 1.45 is 4.33. So this is 4.33x cosine. We have to find omega. Omega is 2 pi over period. 2 pi. We found the period. 0.09. So 6.28 divided by 0.09. 69. Hold on. So 6.28 divided by 0.09. Why this is okay? Let me double check this one. 1 divided by 43.44. 0.02. I'm sorry, this is 0.02. So let's see. 6.28 divided by 0.02. 314. Okay, so this is 314. So omega is 314. 314t. All right, so we're gonna rewrite it. Yt is equal to amplitude 0.007 sine omega 4.33x cosine, and then that's k, not omega. Omega 314 mt. Okay, so this is the equation for this wave. Thank you. I'll see you tomorrow. And tomorrow, don't forget, tomorrow is the test. The test is, if you can count how many nodes here, that would be it. If you can count how many anti-node over there, that would be it. That's all I'm hoping for.